Alright, so we went through our first stage of the simulation. We were attempting to simulate Hardy-Weinberg equilibrium, which is a situation we talked about this in class where evolution is not occurring, right? And we're going to see how well we did with that. And so what we want to look at now is what you ended up with at the F5 generation, so the 5th generation. Okay, we need to collect data on that. And so we need to know how many of you guys end up as being big A, homozygous dominant, how many of you were heterozygous, which is big A, little a, and how many were homozygous recessive. So we just want to do a show of hands, but again, we want to look at this F5. That's the only one we care about, not 1 through 4, that's the last one. Alright, so let's get a show of hands. How many of you guys were, at the end of the 5 generations, big A? Raise your hands so I can see. Big A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of you. 11. So there's 11, big A.
Do we all write that down?
Yeah, you can all write that down. How many of you, raise your hand, were big A, little a, heterozygous? How many big A, little a? 1, 2, 3, 4, 5, 6, 7, 8, 9 of you. So 9 big A, little a. And how many were little a? Little a. 1, 2, 3, 4, 5, 6. And I'm hoping there's 26 people in here.
There were 27 yesterday, plus you.
Well, PJ's absent.
Yeah,
This
that
one here
works
is
out.
2 in here, and Noah's absent. So yeah, 26. We're right. Okay. So we got 26 people. All right. So real quick, somebody's got a calculator handy. We need to do a quick division here. What's 11 divided by 26? 9 divided by 26, and 6 divided by 26. 0.6 and 0.4. Now, comparing these numbers, the initial to final, did evolution happen in case 1? Was there evolution in case 1? There was, right? Who can explain how we knew that evolution took place in case 1? Yeah.
If you look at the decimals, the numbers do not stay the same. They, at least for the homozygous dominant and the heterozygous, it basically flip-flop.
Right, and just looking at the dominant versus recessive, dominant became more common, recessive became less common in the gene pool. So evolution did happen. Now, this doesn't really make sense because we were trying to simulate Hardy-Weinberg equilibrium, which is a scenario in which there is no evolution happening. So if we're trying to simulate no evolution, but evolution actually happened here, what is our explanation for that? Why did we have evolution in this particular scenario? What? All right, that could be one. So I'm just maybe we weren't being random. Maybe you were picking certain people, like your friends or whatnot. So it might not be random. Or small population. Most likely small population, right? For evolution to truly, for Hardy-Weinberg to be true, we need to get very large, like hundreds of students. When you got 25, 26 students, that's a pretty small population. And the chance events could affect your results. We're not too far off of the 0.5 that we expected, but we did veer off of it. And most likely that's because of the small population, genetic driven. Okay? What we want to do now is case 2. If you remember for case 2, if I look at the board here, case 2 is now we're actively going to try to put natural selection into our scenario. And for case 2, anytime you get little a, right? Anytime you get little a, we're going to assume this individual does not survive. We're going to assume they have sickle cell anemia, which in actual, real life, it's not deadly 100% of the time. But to simplify the simulation, we're just going to assume if you get little a, your individual had sickle cell anemia and does not survive to reproduce. So if you pick little a, you put your cards back, you reshuffle, you pick again until you get something other than the homozygous recessive. So in case 2, you should only be big A, or big A, little a. You should never be this, right? If you get this, put your cards back, reshuffle, pick again until you don't get that.